Hello, everyone. My name is Patrick McKenna. I work at GitHub. It came to my attention recently, actually, that my title's probably misstated on the website. I don't really care about that, but if anyone does, I'm a data scientist there. So today's presentation is loosely titled Greatest Hits from Ask Git Core. That's slightly misleading. I want to explain the idea behind it. So I work at GitHub, and we employ a couple of the core maintainers of Git. And the only reason I'm mentioning that is because it makes things really handy when you have a question about Git. Among the hundreds of internal Slack channels that we have, there's one that is a pretty nondescript name. It's just Git users, but it's pretty cool for everyone who works there to be able to jump in that channel anytime they have a question that they haven't been able to figure that out themselves. And as you can imagine, there are a lot of people who work here who have quite a bit of Git knowledge already, so it's really great to be able to go to somebody who really is an expert. Now that said, this is not intended as a tutorial for a group of people who would be very much at home in the contributor summit right now. So if you're a core Git maintainer, for example, this probably going to be a pretty boring talk. That's not the intended audience. And I'll go over my expectations in just a second. I also realize it's a little bit difficult sitting and listening to anybody for 30 to 40 minutes right after lunch. So I'm not going to be terribly offended if some heads go on desks. I get that. And it's also, there's not just one single overarching narrative to this presentation. So if you fall asleep and wake up 5 minutes later, we'll probably have moved on to the next thing already. So you can just pick up from there. So what is this going to be about? It's a selection of how-tos and some general advice for working with Git. That's essentially what we want to go over. And again, most of these are taken from discussions that have happened at one point or another in that Slack channel. So what are my assumptions about the audience here? That you're comfortable with command line Git. You don't need to be using it exclusively. I've spoken with a number of you already who use Git GUIs of one flavor or another. You don't need to be ashamed of that or anything. That's totally fine. But I do assume some proficiency with command line Git, that you understand the basics of its internals, so its fundamental object types and so forth, and that you're familiar with shell scripting, at least at a high level. So if that's just to give you a good general sense of what I'm expecting from everybody else out there. And if you have more specific questions afterwards, I'll be available just sitting in the back. So if you want to come up to me personally and chat about something, I'm more than happy to talk further with you. This is also kind of a tricky audience to always plan for. It's like the long tail of the distribution of like Git users, right? If it's a roughly Gaussian, we have a long tail here. So there's a wide variation in terms of like level of background. So I'm trying to hit the sweet spot in there. All right. So the first thing I want to go over is just simplifying some common tasks. And this is going to be relatively straightforward here, I think. But if there are questions out there, by all means, ask them. You can follow along if you like, just with whatever kind of scratch Git repos you have on your own machine. There aren't going to be any particular ones that I'm using for the purposes of today's talk, so I'm not going to ask you to clone anything. But let's start with one that came up. It's how do I know what commits were added to a given branch that I just pulled from? So there are a couple assumptions baked into this right here, but assume during the course of your workflow you've gone into some particular repository, just typed git pull, say you're on master. I'm assuming a lot of conventional uses of Git right here, of course. And you want to figure out, okay, so I see this printout of things that just got fetched down from the server, but what commits were actually just added to, say, the master branch? If I was on master, I typed pull, and the usual arrangement, master tracks origin master. So it'd be kind of cool to be able to come up with a simple script or git alias, git show new, followed by some branch argument right here. And so we're just going to go through the basics of what that is. So the first thing we want to do is to be able to accept some branch as an argument and provide some kind of sensible default if the user doesn't supply any. So that might look something like this right here. So first check to make sure that there is an argument actually passed that's not an empty string, and if so, assume that's the name of a branch. And if there's no argument passed, then we're just going to go ahead and assume that you mean head. And again, so I'd assume everyone knows what head is here. And if there are questions on that, by all means, please raise your hands. Okay, so the next thing we need to do, we need to actually generate the list of new commits. All right, and we're going to use a plumbing command called git revlist. Raise your hands if you've used this command before. Okay, see a smattering. There's always like the half hand up too, which I don't know if you used half the command or, okay, so what is git revlist? So it generates and traverses commit graphs. You're not going to be using it much in your day-to-day life with Git on the command line, but it's a useful one to know, or to look up. And it's what we're going to use in order to get this list of commits. So what's the general syntax for commits that are reachable from A and but not B? It's going to look like this. That's one incantation. Git revlist A caret B. So A and B here are commit-ish. So if you've come across this phrase before, it means anything that can ultimately resolve to a commit. So it could be a commit object itself, it could be a branch, it could be a tag, and so on and so forth. There's an alternate syntax here, git revlist B _A. I would definitely recommend using the former though. The latter is kind of cryptic, that ordering. It means exactly the same thing as what's on top, but at least the caret symbol there in certain languages and environments actually means like a logical not operator. So I think that's clear to some people. So I haven't seen any other place where B _A means not B and A. So for the sake of clarity, I'd recommend the former. So in our case, what are A and B actually going to be? A is going to be the commit to which branch currently points, and B is the commit branch pointed to before you last pulled. All right, so how do we specify the commit that branch used to point to? That's probably the part here that people are least familiar with, I'm guessing, based on just personal experience and chatting with others. So there's this special syntax, @ symbol, curly brace, n, and n here is an integer. So that's going to look something like this. Now that looks kind of exotic, and it is, and I'm going to go over a little bit more what I would recommend in terms of using Git syntax like this. But what it's going to get you is the nth prior value of branch. So where did that ref point 1 time ago, 2 times ago, and so on and so forth. So in our use of Git revlist, we're going to look at something like this. Show me the list of revisions, the list of commits that are on branch, wherever branch currently points, but are not on wherever branch pointed 1 time ago, before the last time it moved. And incidentally, I'm going to be making these slides all available too, so don't feel like you need to copy everything down verbatim. You can if you like, and if you learn better that way, or if you just care to, but it's not necessary. So put all together with a little bit of extra like formatting of the print output, you might get something like this. For that, git show new. Get your branch name, print out the number of commits that were added by that pull, and then just pipe out what the actual commits were on 1 per line. And you can format this a bunch of different ways. I'm not going to claim this is a bulletproof script by any stretch, but just as a kind of proof of concept for how you might go about doing this. So that's useful because I think there are a lot of times in a given day, or certainly within a given week, where people will ask this question. It's like, all right, I realize I just got a bunch of updates on master, but what did I actually just get there? And it is actually printed out for you, this information, right after you type git pull by default, but not in a nice format, just like this. So some related advice. Be careful with that convenient syntax, the @ symbols. So as mentioned, I was going to come back to this because it can be pretty cryptic. So there was a line like this. This is actually taken, this line used to exist, I forget in what GitHub repository, but it was there. And some engineer came along and looked at it, and they said, what the hell are all those @ symbols? What does that mean? And that's a totally reasonable question. If you hadn't seen it before, it's not self-evident. So does anyone know what the @ symbols are? There's a technical answer to this. So it's this. Yeah, no, real answer, yeah, that's one of my favorite lines from the chat room, yes. So this is coming from a core Git maintainer, right? And tongue-in-cheek, of course, but yeah, but the idea is these are not obvious, right? So you don't necessarily want to include them, certainly not in your scripts. But just so you know, the @ symbol with nothing else after it is short for head, and the @ curly brace U is @ upstream. So that's what's technically going on there. But another opinion expressed by a different maintainer. So using the scripting is a horrible idea. Don't use this kind of shorthand, which is really nice. Maybe if you want to save a few keystrokes on the command line, but if it's in a script, use the long form of option switches and so forth. Git, as we all know, can be tricky enough as is, right? So there's no reason to just make it even harder. Make scripts reader friendly where possible. And again, this is advice is coming from people who work on Git on a daily basis too, and so they're finding it a little cryptic at points. So you might this is actually a diff taken from a pull request that updated that particular line in whatever script that was to make it somewhat more readable. And that's definitely a practice I would recommend sticking to. Okay, so I wanted to go over a few things, tips for integrating with Git. And what does that mean? That's a very generic phrase, integrating with Git. There are just a few cool features that I don't think most people know about. I certainly didn't until I read that. And one is how you can add some metadata to branches. And the second has to do with using exclude patterns in external tooling, say scripts of one sort or another. So what do I mean by add metadata to a branch? There's this nice option switch to Git branch, -- edit description, give it a branch name, and it'll pop up in your editor, and you can go ahead and add whatever text you like in there. So this is really handy because human beings, like developers, we oftentimes think in terms of branches, and you try to capture some meaning within a given branch name. At least I'd recommend you do. Certainly, don't just put Patrick's branch or Saturday experiment or something like that. Give your branches meaningful names, but sometimes you want to put a little bit more in there, maybe a sentence or two describing what it is that you intend to actually do on this branch. And you might have some tooling that is going to be looking at different branches and looking for some kind of metadata like this. And this data is then written to Git and config. And the nice thing about it is it follows renames, and it's deleted when your branch is deleted as well. So Git's going to clean up after itself. And this is actually a very good use case for changing what's in Git config. Git config is meant to be extensible for a lot of third-party use cases. So if you ever find yourself trying to write any kind of tooling, your homebrewed stuff for your own interests or some part of larger project, Git config is very much an okay place to dump some extra information for things like this. The next thing I wanted to cover is using exclude patterns in scripts. So what do I mean by exclude patterns? I mean the kinds of things that are going to show up in your git ignore files or just git info exclude. And in case anybody's not sure what the difference between those two is, git ignore files are typically tracked as part of the repository, so they go in your commit history and so forth. Git info exclude is a place that lives just locally. So if you want to exclude certain files, but you don't necessarily need to include that exclude pattern, like as part of a commit, as part of the official history of the project, say because you have some local scratch files that you use, dump it in the second location. But it's nice when you're, say, building a testing script to make sure that your test scripts aren't going to go look at whatever dummy files you have lying around, that they're actually going to respect whatever exclude patterns you've defined for the project. And it's, of course, possible to re-implement the logic behind Git's exclude patterns, but it's non-trivial, and you're just asking for extra work, so why do it? So the essential plumbing command you want to know about here is git check ignore followed by a path name. All right, so this is going to return path name if it matches one of the exclude patterns. So you can either pass this a single file name, or you can pass it a directory, and then it'll list any files in that directory that are matched by an exclude pattern. So if you have a list of files that you want to say run your test scripts against, pipe them all through this, and you'll only get fed out those that should be ignored. And a lot of different testing scripts will have some kind of mechanism for telling it to ignore certain files. Now this does have a few problems with it. There's no recursive option for wildcard searches. So if you're looking at this, assume that git ignore includes star sample.py. If I type this command, you'll see git check ignore plugin /star. it's going to tell me, okay, yes, there is a file that fits that exclude pattern at the top level of plugins, but if there's one nested one layer deeper, it's not going to return that. And there's no option switch for check ignore to tell it to just recursively descend through all directories and find everything. So that's kind of a pain because that means you'd need to actually list every top level and subdirectory of that you might use in your testing scripts. So there's a somewhat better option too. Oh, there's a couple other restrictions I want to point out. You can't filter against a custom ignore file. Check ignore is very much tied into the way Git defines exclude patterns. And it's actually not listed on the website, but it is there. It follows the same URL, so actually I should just open a pull request to add it. Or any of you could, because git-scm.com is an open source project. It is there, but it's not listed on the index. So we can solve those first and third issues though, right? Not having that recursive option and having a command that's actually listed on git-scm when we use git ls-files with the --others flag. And this is going to show all untracked files, and it is going to work recursively as well. So to give you an example from another repo that we happen to work with, we have one repo that I spend a lot of time in, has a git pre-commit hook, and I believe you learned actually more about git hooks just a little bit earlier today, that it's going to do some Python linting, so nobody can actually commit unless their Python files pass the PEP8 linting test. So it looks something like this. To find some directories where your Python files live, PEP8 is a command to just do exactly what I was mentioning, check some style conventions for Python code. So what it's going to do here is say, okay, git ls files, show me all the files that are excluded that live in one of these Python directories. The PEP8 command expects the list of excludes to be presented in a certain way, a common delimited list. So that's why there's the pipe there, but you can ignore that for the purposes of understanding the git command. And so this is useful because, for example, I end up having like a couple scripts that I keep locally that I put in the git info exclude and are just for my own testing, and maybe I even just jot down some pseudocode or random notes, and I don't want to not be able to make a commit just because I wrote a note to myself in some file that's supposed to be excluded from the project. So there's that. Now the next thing I wanted to come to is moving history between repositories. And this is going to go over a few commands that we also touched on earlier, but I checked with Kyle, and I don't think he actually did this version of things, so this isn't going to be redundant, I don't think. But let's assume there's a scenario where you have two separate repositories that have been developed independently. They each have their own independent history, haven't referred to each other up to this point. And what you want to do is take a subdirectory that lives in one of these repositories and move it over into the other. So you don't want to take the whole thing, you just want a subdirectory, and you want to move it into some target repo. And you also want to preserve the history as well. Okay, so this is the use case. So a simplified version might be something like this, right? Beforehand, subdirectory exists in source, after it exists in target. And why would you be doing something like this? You might have a repository that's grown to include a bunch of different code, and maybe you've decided architecturally we want to go towards like the microservices world or some other buzzword of the day. Whatever reason, you want to split your repository up into multiple components. This is definitely something that happens on a semi-regular basis, I think, certainly at larger organizations. But it's a one-time operation. Right, so we're not going to be using submodules or anything like that because this isn't a replacement for any kind of dependency management system or package management. It's just a one-time thing to split apart a large project. And we're going to assume that subdirectory doesn't exist in the target repo. It's not too difficult to modify this example if that is in fact the case, but we're going to assume for simplicity that it's not. And then we want it to just keep the same name. So if it was called docs in the original repo, let's just still call it docs in the second repository. So the first thing we need to do is actually construct a synthetic history. And what does that even mean? Well, remember, we're just taking the subdirectory. We don't want the commit history of the entire source repository. We just need the commits that touch whatever is in the subdirectory. So that's what I mean by that. So here is where the subtree command that I believe you were hearing about earlier comes into play. The idea is, okay, so in the source repository, git subtree split, give it a branch name and give it a prefix. So what do I mean by that? This is going to create a new branch, and it's going to synthesize that commit history in the manner I just described. So any commit that touches one or more files that live in the subdirectory is going to be included in this synthetic history. But all the files that live in the subdirectory are actually now going to be at the root of the project. So that might be a little bit confusing, but the idea is we need to pretend like none of the other contents of the repository exist. So that's why this is happening. And so you note, if you run this operation repeatedly, you should get exactly the same results every single time. This is, of course, going to create a brand new set of SHA-1 hashes because we're having to artificially reconstruct history, and we're getting different trees from the very beginning going forward. But those hashes should be the same every time you do this. Okay, so then step 2 is going to be, let's get everything in that subdirectory into the target repository. And there are a couple different ways to do this. We're going to start with the simplest one. So in the target repo, git subtree add -- prefix. And the subdir argument here is, okay, what do I want it to actually be called in the target repository? And again, we were going to assume for simplicity that we're just using the same name. Then you just give it the source repo and whatever branch it was that you had just created in the previous step. And right there, source repo can be anything. It can be a path on your local file system. It could be a URL, anything that Git understands. All right, so that seems pretty straightforward. And what's going to happen when you do this? It's going to import that synthetic history, and it's going to put all the contents in the subdirectory. So it's pretty much exactly what you want, right? There are a few caveats, though. That may not work in exactly the way you expect. All the commits will be there, but some common commands that you might want to use afterwards and expect to work in a certain way won't necessarily. So git log, I think, is the best example of this. So assume now in my target repository where I've just imported this subdirectory with all its history, I want to look at the history of a given file, right? Part of the idea of this is we don't want to just bring over the files as they currently exist, we want their full history. So we would do something like this. Git log, I think most people have seen this invocation, so space, -- space is to say, okay, don't show me, all commits, show me only those that touch the patterns after the double dashes. So git log, subdirectory, some file within it. And you're going to see a commit that looks like this. And this is the commit that gets created when you ran git subtree add. Okay, so that gives you a lot of useful information right there, but it's actually the only commit you're going to get. Now assume file, whatever that is, has a much longer history in the first repository. You'd expect to see all that right here, right? That was the whole idea of bringing over all of the history. But you don't, at least by default. And adding -- follow, which is the flag that one would typically do to track renames of a file, the history of a file, including renames, is not going to fix the problem. There's a kind of hacky workaround. If I just put a wildcard before the file name, this will actually output the list of all of the history of the file. But there's some problems with this. It's not a very robust solution, because what if you have to have the same file, but within different directories, it's going to catch all of them. It's not going to filter in quite the way you want to. And that's what I mean by some of the limitations. So there's a second way to do this, actually. And to be perfectly candid, I did not figure out right before this why this was happening, and that's still something I want to do. So I think in the version of the slides that I end up posting, I'm going to put in a better explanation for this. So I apologize in advance for not having that. But this is going to solve that problem for you. So if you go to your target repository, and instead of running git subtree add, we're just going to do a few other commands. Check out a new branch. It's Git. Branch creation's cheap. You should be creating them all the time. And this is a kind of tricky and perhaps new operation, so let's experiment on something new. You're going to add as a remote whatever your source repository is. That -f flag just means fetch, so as soon as the new remote is added, we're going to fetch from it to get all its references on all its objects. And then we're going to use a special version of the merge command. Now, by default, Git does not let you merge branches that have no common base commit. So you have to pass it this allow unrelated histories flag in order for this to work. But once you do that, and you say, okay, merge into my new branch, the branch where I made that subtree in the source repository, you're going to get the same results in the terms of the commits that are actually introduced into your new repository. And something like git log -- path name is now going to work as expected. So you'll not only see a commit message that looks like this one earlier, but you'll see however many others existed for however many other commits touched that file in the source repository. So again, those 3 steps will look like this. So some general notes on history manipulation, which is, of course, a tricky thing in Git. It's very powerful, of course, and there are a lot of different ways to do it, many different use cases. So just a few notes that have come up in discussions in that Slack channel about these kinds of issues. Filter branch, a command many of you have probably heard of, is a very powerful thing. It generalizes better to processing all branches instead of just one and doing many other fancy things. But it's notoriously tricky to use. Notoriously, not just in the sense of like, okay, people on Stack Overflow complaining like, okay, what did I do to my repository? But no, even people who work with Git on a day-to-day basis and who are intimately familiar with it, it's really easy to screw up. So just be very careful with it. Subtree has the merit of being a lot simpler, but there's this other caveat that it actually lives in contrib, which is, so if you go look at the source code for Git, there's a contrib subdirectory, and so this is not going to, the subtree command, by default ship with every version of Git. You can always get it if you just build from source, and a lot of distributions will include it. So for example, on Mac OS, if you have like Homebrew installed Git, you're going to have the subtree command included as part of that, but not every platform is going to get it by default. Filter branch, on the other hand, does ship by default with Git. And for those of you that are curious, contrib, if you go look at it, is a bunch of stuff that is like not quite fully baked into Git yet. It's stuff that's been pretty well developed and will probably get included at some point in the future into all versions of Git, but is not necessarily there yet. So there are a lot of interesting commands there. So a couple related history manipulation tools that I just want to point out. No stories around this, but just a few bits of like wisdom that I thought were kind of cool and that you kind of have the advantage of getting when you have a chance to chat with people who are working on Git on a regular basis. Say in one of these cases you wanted to create a completely new history, start from some arbitrary point and just disconnect from everything else. Git checkout -- orphan is going to let you do this. So pick an arbitrary point in your commit graph, say I'm going to create that as basically the start of time and move on from there. Some people may choose to do this if they're migrating from, say, some other version control system to Git. They don't care about history past a certain point. There are a lot of potential use cases here, but that just being one of them. And then if you want to do an abbreviated history of sorts, like just I want to take the middle chunk of the commit graph or something, that's going to get a little hairier. We definitely don't have time to go over a full-fledged example of that, but filter branch with graphs is what you're going to want to look at. Again, though, it's a very powerful tool. It's easy to shoot yourself, not just in one foot, probably both feet, repeatedly. So just be mindful, that's all. So some final tidbits I wanted to include. So again, this is no full examples here, but just things to keep in mind. And this one I put in here as something to keep in the back of your mind when you're trying to understand conceptually what's going on with Git. It's really important. As I started out by saying, as people, we really like to think in terms of branches, right? Just logically it makes sense. Git really doesn't have a notion, though, of a commit being made on a particular branch, right? Branches, references more generally, are conveniences for humans to be able to understand a directed acyclic graph of commits. But people often want to think of, oh, Git should know that I was on this branch when I made this commit. It really doesn't. And being able to internalize that, I think, will, to a very mild degree, perhaps take away some frustration when you're trying to figure something out. So that's important to bear in mind. Another thing that somebody figured out, Git is not going to expand built-in commands when you use them as aliases. So for example, if I try to create a Git alias that uses the name of a command, like branch, for example, but with some other flags, so that whenever I type git branch, it's going to be branch with those additional flags, that's not going to work. Interesting bit of history. This apparently was debated many years ago by Git core, like should we allow people to create aliases that have the same name as built-in commands? And this was actually a case of Git saying no because we don't want people to hurt themselves, which I think a lot of people think is contrary to the pattern of Git, where it's like, yeah, it's an all-powerful tool, just be careful. If it hurts, don't do it. So I thought that was kind of interesting. But if you ever run into problems creating your own aliases, make sure that you're not trying to alias the name of an actual built-in command. If you want to be writing your own scripts that are going to be manipulating Git objects, check out Git sh setup, this little scriptlet as it's called. It'll help you out in a number of different ways. It takes care of a few sometimes problematic environment variables depending on what kind of operating system you're working on, and it includes some helper functions too, like make sure that you're in a valid Git repository, that your version of Git actually understands, and takes care of some other plumbing tasks that anybody who's really scripting and working directly with Git ought to be doing. This just has it for you. So that's again, just go look at the Git source code, and that's one of the things that's included. If you ever want to contribute to Git, Git still operates with the mailing list. All right? So there's like a mirror of Git on GitHub, for example, but they don't accept pull requests. Somebody did, though, create this pretty sweet web app to go ahead and make it easier to start trying to contribute to Git core. So if you ever find yourself in that position and you really want to do something, check out submitgit.herokuapp.com. And that should make wading into those waters a little bit gentler when you want to try that out for the first time. And then lastly, I want to give a shout out to a project that was developed by Mike Haggerty, who's one of the core Git contributors, called Git Merge. If you haven't heard of this before, I highly recommend that you check it out. I actually gave a presentation on it at last year's Git Merge conference. But broadly speaking, it really makes the pain of merge conflicts go down. I'll leave it to you as for outside reading to go ahead and figure out more about it. But what it basically lets you do is walk back if you're trying to merge two branches and figure out where conflicts originally occurred. So it's going to walk the commit graphs along, say, two branches that you're trying to merge and say, hey, these are the pairs of commits, like, you know, this many days back on each branch where this particular conflict first got introduced. And you solve these conflicts one bit at a time. So rather than dealing with one giant merge conflict at the end, you get to deal with the conflicts as they come up as you're traversing this commit graph. Now it does this, but it's also very quick. It's surprisingly efficient. It uses some Git bisect-like algorithms to achieve that efficiency. And it has a bunch of really cool ways too of how you save the end result. So if you want to just use this as a tool to deal with nasty merge conflicts, you can do that. If you want to do that and save interesting versions of your history that include how you resolved all of that, you can do that. And perhaps coolest of all, you can save a partially resolved merge conflict, push it to your favorite Git hosting service, and let somebody else work on it. So if you have a particularly nasty merge conflict that, say, you know how to resolve in part, but not completely, you can fix part of it with Git Merge, push your results up, somebody else can pull it down, and then continue, and you can go from there. So being able to save the state of a partially resolved merge conflict, I think, is really rad. So he has not paid me for this. No, it's just an open source project too, so if you want to contribute or has some functionality you're missing, it's there for you to work on. But these are some closing some bits of tips that I thought it'd be cool to include. So that's everything for today's talk. I think we have a little bit of time. We got some amount of time left too. So I'm happy to stick up here for questions, or if anyone wants to approach me individually afterwards, you're more than welcome to. I'll be here both today and tomorrow. But thanks for listening. I realize it's probably the toughest time of day to keep your eyes open, and I haven't seen too many heads on tables. So thank you for that. So it's, yeah. Oh, so we got a mic coming to you too.
Thank you.
Yeah.
And when you merge two histories with unrelated changes, what will be the merge base?
So there isn't a merge base, right? So to work on. So that's why you need to pass that allow unrelated histories flag, so that Git knows not to look for a merge base. It's adding in those files, but brand new, and constructs a new tree. It doesn't try. There's no merge base for it to go back to try to work from. Right. Does that answer your question? Sort of. Perhaps we can. Okay. Okay. Anybody else? All right, so everybody gets out early for good behavior. And yeah, I'm more than happy to chat with any of you individually if you like, but thanks again. And hope you enjoy the rest of Git Merge.